Hello and welcome to the Blue Open Studio tutorial video series. The topic of this video will be recipes. In this video, we will be discussing the different types of recipes, how the recipe feature works, properties of the recipe worksheet, and we will demonstrate creating a recipe worksheet, managing, creating, saving, and loading recipes, locating recipe files in Windows Explorer, and viewing recipe files outside of Blue Open Studio. While recipes are configured via Worksheet, the individual recipe data are stored in external files. The external data files can be one of two types, a standard XML file or space-separated DAT file. Each file type has its own benefits and limitations. We'll first look at XML recipe files. And the XML file stores the data in an easy-to-read XML format that can be processed by other programs or viewed in a web browser. The tag names are saved with the tag values, however, so the values can only be loaded back into the same tags. And how the process works, you first have a recipe configuration file, which is an RCP, which corresponds to the recipe worksheet. Then with a save button or trigger on a screen or through a script, you would save the recipe with a name, then the .xml format. And then that would be written to the hard disk. And then via a load button or trigger through the application, that same data would come in under the same recipe name and be loaded back into the recipe configuration file. In contrast, the DAT recipe files store the values as raw data without tag names. A separate RCP file that contains the recipe configuration is saved and associated with that DAT file. That means one recipe worksheet can save tag values to the file, and another worksheet can load the values into a different tag group or in a different order. This is important to remember because this could cause data corruption and/or issues with recipe management if you're not careful to identify what parameters go with what values. In contrast, DAT files store the tag values as raw data without tag names. There is an RCP file that contains the recipe configuration associated with the DAT file. So what that means is that a recipe configuration file will instruct what data needs to be stored, and through a save action, be it a button or trigger through the application, that data will be saved off as a DAT file onto the hard disk. Then a load trigger or action through the application can read the information from that DAT file off of the hard disk and then read it into another recipe configuration file. It could also go to the same file. So what this means is that one recipe worksheet can save tag values to the file, and another recipe worksheet can then load those saved values into different tags or in a different order. This is important to know because this could cause data corruption or issues with recipe management if you're not careful, because there are no tags associated with the values. And we will begin by first creating the recipe worksheet. So in the Blue Open Studio development, in the Project Explorer, I will go to the Tasks tab, and right below Trend is Recipes. I'll right-click and select Insert, and it will open the recipe worksheet, and the layout is similar to any of the other feature worksheets that we've seen so far. We have a header at the top, and then the body of the worksheet. And in the header, we have a description field, and for us, we will put in sushi recipe. And then below that is the file name field. This can be a static string for the file name or a tag that you can enter inside of curly brackets. If you notice, if we right-click on the field, you do not get the insert tag or expression. So we will have to manually type in the tag. And as I mentioned, the tag will need to be inside of curly brackets. So I'll do an open curly bracket and then type in the tag we're going to use, which will be recipe name, and then close curly bracket. And then when we click away, it says the tag does not exist. Would you like to create it? Yes, I'll create it as a string with local scope. I'll click OK. And then we have to the right of that the register number field. And in this box, you would enter a tag that would define the register number to be read from or written to in a database file. Now this is here for legacy purposes only, and it should not be used in a new recipe worksheet. So it's simply for support of older applications. There's no need to use it in newer development. And then the options to the right of that are two checkboxes. The first is Save as XML. This is the option whether you want to save the recipe files as either XML or DAT files. If you have it checked, it will be XML. If you uncheck it, it will be DAT. And that's what we'll do. We'll actually uncheck these and save them as DAT files. And then below that is the Unicode option. And with it checked, it will save the data in Unicode format, which is 2 bytes per character. Or if we uncheck it, it will save it in ANSI format, which is 1 byte per character. And we're going to leave it set to default. And then in the worksheet body, we have 2 columns. The tag name, which will store the name of the tag that we will be referencing for the recipe, and the number of elements. Now, the number of elements is specifically used for arrays. So I could enter in a tag name here that's an array and give it the starting element. So I could start halfway into the array, or I could leave it blank and it will start at the first element, which is element 0. And then I would put the number in here. So for example, if I wanted to use the first 10 elements of an array, I would put the array tag name in here and the number 10. And it would take elements 0 through 9. Additionally, you can enter in a tag in this column inside of curly brackets. And then you can dynamically set how many elements this recipe will read or write. For us, we are going to enter in items of the sushi class that was created in a previous video. So for the first row, I will right click and select Insert Tag. And I will go to Project. And then in the selection box, I will start typing in sushi. And then I will select the sushi class, click on the member button, and then select Nori. Click OK twice to bring it back into the worksheet. And then for the next one, I will copy sushi Nori and paste it. And then I will simply change sushi Nori to sushi.rice. And then I will paste again. And then change it to salmon. And then I will type in the fourth one, which is sushi.tuna. And then in the number of elements column, since we're only going to be reading in those individual tags, we will just set them all to 1. Now there is one more tag we want to enter in here, but we have not created that member yet in the sushi class. So we'll first have to do that. So in the Project Explorer, we'll go back to the Global tab, and we will expand our Classes folder, and then expand the Sushi class, and then double-click on Datasheet View, and then we'll enter in our new member, which is Wasabi, and we'll leave it as an integer. And then I will close the class, and now I will right-click on the empty row in the recipe worksheet and select Insert Tag. And this time on the tree list to the left, under Project, I will select Class, and then I will select Sushi in the main window, click on Member, and now our new member that we created, Wasabi, appears. I will select it and click OK twice to get back to the worksheet, and then just enter in a value of 1 for the number of elements. Now we have our recipe worksheet configured, so all we have to do is save. Then when I go to save it, it comes up and asks to enter in a file name, not a number, but a name. And this is important because when we save or load the recipe, this name will come into use. So we will just give it a very generic name of recipe 1. And this name is independent from the description. The two can be the same, the two can be different, it really doesn't matter. So once I enter it in, I'll click OK. And if I go back to the Tasks tab and expand recipes, we now see my new recipe show up. So now that we have created our recipe worksheet, we can now develop the screen to interact with our recipe. So I will close my recipe worksheet, and then I will go back to the graphics tab, expand our screens. I will open the template screen, and now I will save it as a new screen, and I'll name that screen recipe. So we now have to create the interface for reading and writing the data for the recipe. There are a few ways to do this. We could use a grid object, which will be covered in another video, or we can simply use text fields or text boxes. So we're going to go with the simple way and use text data links. So I'll first go up to the graphics menu on the ribbon, and I'll select text under active objects, and I will click, and I will first type in our sushi name field. So I'll type sushi name, colon, and space. And then I will double click to open the properties. And I will click on text data link. And for tag expression, I will click on the browse button to bring up the object finder. And then for the tags off on the left-hand side in the tree list, I will filter out to view the strings only. And I will select recipe name. And then I will enable input. And virtual keyboard, I will set for alphanumeric. And then I will go back to text because I will need more than 4 characters for the name. So I'll expand this out to 20. Now that we have the sushi name field created, we can now create the other fields for each individual parameter for the recipe. And we have a total of 5. So I'm going to copy sushi name, and I'll open the properties. And for the tag expression, I will replace this with the first class member that we want to use, which is the sushi.nori. I will leave input enabled, but I will change the virtual keyboard from alphanumeric to keypad because we only need to enter in a numerical value for these fields. Then I'll click back to text, and I will change the caption to nori, colon, space, and then I will put in 3 pound signs because at the very most, I want to be able to just put in 3 digits. And now with that one completed, I will copy that 4 more times. And then I will bring up the object properties, and I am first going to go through and change the tags, and then I will go through and then change the captions. Because as you've noticed inside of the software while you're using it, you can quickly switch between objects and leave the properties window open. And if the objects are the same, it will remain on the same page or property tab. So for example, if I come into the second one and I change sushi.nori to the sushi.rice, and then went back to text, and then just changed the caption to rice, and then I came to this one, I would first change the caption and go to text data link. So one way to do it would be to go through each one and change the one property and then go back through and change the rest, which is what I will show you now. So on the third one, I will change nori to salmon. And I will change the fourth to tuna. And the last one to wasabi. And now I will go into the text data link and change the member name for each. And now we have our 5 parameter fields properly configured. Now if we look, these don't look laid out very well. So I'm going to select all 5 of them, come up to the ribbon to the Format tab. I'm going to expand the Align option and select Distribute Vertically. Now they're laid out a little more evenly and it looks a little better. So now that we have the options for reading and writing not only the recipe name, but the parameters as well, we have to configure how we save and load the recipes. And if we go back to our recipe worksheet, you see there is no option here for triggering a save or a load. And that is because the recipes are saved and loaded via a built-in function. So we will first look at that function. We'll bring up the tech ref and I will search for recipe. And when I look at recipe, this says it's the built-in function that executes a specified recipe worksheet. And it has a single argument. But this argument contains two pieces of data. The first is the operation and the second is the file. So for the syntax, we see that it's the operation, colon, and then file. And for operation, we have four options: save, load, delete, and initialize. The save, load, and delete operations are self-explanatory, but the initialize will retain the structure of the recipe file, but initialize all the values back to 0. So this is useful if you want to save the recipe off as a different name and use that as a blank or a starter for a new recipe. And then for the file name, that is the name that we gave to the recipe worksheet, in our case, recipe 1. And then we have what the return values are, and down at the bottom are the examples. As you notice, the argument has to be put inside of double quotes. So we go back to our development, and we will first place a button on the screen. So I'll go to the graphics tab of the ribbon and select button under active objects. Click and drag to draw. Inside for the caption, I will change it to save. And under command, I will go to on up, and I will change the type from VBScript to built-in language. And here what we will do is we will actually create a new tag that will receive the return value for the function. And the tag name will be REC status. And it doesn't exist, so we will create it as an integer with local scope. Then for the expression, we will type in the function recipe, and then open parenthesis, open double quote, and then save, colon, and then the recipe name, which is recipe 1. Now here's the important part. We also have to put the file extension. So it's recipe1.rcp. Close quote, close parenthesis. And now when we click away, it comes up with no errors, meaning our syntax is correct. So now we have an option for saving the recipe. But we also have to create one for loading as well. So I am going to copy the save button, and I am going to go back to the on up tab for the built-in language, and I am just going to change the word save to load. And then I will go back to the button, change the caption to load. And now we have both the save and load buttons configured for accessing our recipe file. So now I will save my screen. Once we save, I will close the recipe screen and the recipe worksheet. So now I will have to create a button for navigating to the screen. So I'll go back to the graphics tab and open my navigation screen. And I will copy the trend button, and I will change first the open function from trend to recipe. And then I will go back and change the caption to recipe as well. I will save, and then I will close. And I will then snap my development to the left side of my screen, and I will start the runtime. Then I'll snap the runtime to the right side of my screen, and I will go to my recipe screen. Now before we enter anything in, I'll first go back into development, and I will add my new tag that I created to the database spy. And that will be REC status. But there's also another way we can monitor recipe functions. In the output window, if we right-click and go to Settings, we will see a Recipe/Report option. This is already checked because we used it to monitor reports in a previous video. If it's not checked, you can check that, and then whenever a recipe operation is executed, be it a save, load, delete, or initialize, you will get an entry in the output window telling you what function was executed and what the result was. So now we have two ways to monitor our recipe processes. So now back in runtime, I will enter in a name, and I will give it a simple name, roll 1. And I'll change nori to a value of 11, rice value of 22, salmon 33, tuna 44, and wasabi 55. And now with my values in there, I will click Save, and we see that the RAC status tag has a value of 0, which in the return value, 0 means that it was completed successfully. And we have validation of that in the output window. It shows the function save, and it gives us the path and the recipe file name, including the extension, the status, and what the recipe command returned value is, which is a 0. So now we saved it properly. So let's save another one. So let's change this to special 1. And then for nori, we'll make this a 99. Rice will be a 88. Salmon, 77. Tuna, 66. And we'll leave wasabi at 55. And then we will save again. And you see that once again we get another entry with the operation selected, the path, and the file name, the status, and the return result. We've seen how to save the recipes. If you want to load them back in, let's say we want to load in our first recipe we created, which is roll 1. I would come in here and change this back to roll 1. And then just click load. We get another entry in the output window, and now we see our values for roll 1 return. So with this process, you have to type in the name manually in order to load them. There is one other way. It's a very simple way to select what existing recipes are available. So now we've seen the basic method of saving and loading recipes inside of Blue Open Studio. Well, the processes themselves are relatively straightforward. Loading the recipes can be a little laborious because you have to type in the name. There is no pre-canned way to select existing recipes. There are several different ways to remedy this. You could simply write down the names on a piece of paper, keep them next to the terminal, or you could create a screen that gives a list that you can reference when you are entering them in. But there is a built-in function that we can use with some additional coding to bring up a selector or a file browse to pick the existing recipes for the application. And I will show you how to create something like that. So I'll go back to the development. I'll maximize the window. I will open my recipe screen, and I will copy the load button, and I will open up the properties. And first I will go back and change the caption and add the word selected. And then back in command, the on up tab, I will change it from the built-in language type to VB script. Now the function we're going to use is called RDFileN, and it's short for read file in. And this function launches a file browser window allowing you to select a file. And there are several arguments available for this function. The first is the selected file, which is a tag that has to be entered inside of quotes. And that is because you are giving it the name of the tag you want to use to store the path and the name of the file. If you just put a tag in without quotes, it will attempt to read the value in from that tag as the value for this argument. Then we have the search path, and this is the default path of directory used in the file browser to search. And then we have the mask, which is a filter for what file types you want to look for. Say, example, you could put in star.txt for text files or star.doc for Word documents. And then we have the optional flag for changing directory. And if this parameter is omitted or it's set to true, meaning a non-zero value, then when the file browser window is open, you will be allowed to navigate away from this default directory, from the directory contained in the search path parameter. If it is set to false, then the browsing will be restricted to only this directory. So if we scroll down to the examples, we see a simple one here, and with the exception of the last optional parameter, every other parameter has to be enclosed inside of quotation marks. So we'll go back into development. So now what I could do is type in all of the script here, or if I open Windows Explorer and I go to the BOS Training Files extracted zip folder, you will see a text file called load selected button. And inside of this text file is all of the code that we need. So I will copy out of this text file and come back into development and paste it into my button. While we will cover script in more detail in another video, I will quickly review exactly what these few lines of code do. So the first actual line of code, because anything in green is a comment, the first line of code is the RDFileN function, and we give it the tag name of temp and the starting directory to search for get app path, and that is a built-in function that returns the directory where the application file or app file is located. Then we give it a mask of star.dat, so we'll only look for files with the DAT extension. And then we give the optional parameter for changing directories a value of 0, meaning it will lock it to this get app path directory. And then below that, we use the VBScript function replace to search the value in the temp tag for the pattern from the get app path function, and we replace it with a null value, so essentially we delete it. Then we do the same for the recipe name, where we search the temp tag value for the DAT pattern, and then we remove it. And then we execute a load recipe. So quick overview: launch the browser to select a file. Remove the path from the returned value from the browser. Then remove the extension from the value in temp just to get the recipe name, and then load that selected recipe using the recipe1 configuration file. So I will right click and select check script, and the tag temp doesn't exist, so we will create it. We'll make it a string with the scope of local. Click OK. And then it says script is OK. So I will now save. And as you see, we now have our new button. But before I click on it, just to give us a better understanding of exactly what the code is doing, I will come back into development, close the properties window, snap it to the left, and I will enter in our new tags, which is temp. And I will also enter in the recipe name tag. So now, when I click on load selected, it comes up with a browser window. And I have my two options, role1 and special1, and both with the .dat file extension. So if I click on special1 and click OK, you now see that the temp stores a special1.dat, and then recipe name is special1. Additionally, if you would like to see exactly what's going on in this script, there is a built-in function that is useful for debugging. So what I will first do is I'll enter it here, and it is called trace. And trace, all that you do is you put either a static text inside of quotes or a tag in. So in this case, I'm going to put the tag temp, in. And then what it will do is when it reaches this line in the code, it will spit out its value to the output window. And this last one, I will make recipe name. So you see I entered temp after the RDFileN function, then after the first replace, and then I also entered recipe name after the second replace. And I will now save. And I will clear the output window by right-clicking and selecting delete. Also, you need to go into settings and make sure that you have your trace messages option enabled. And now when I click load selected, I will pick roll1.dat and click OK. And you see now that roll1 has been loaded. And if we look in the output window, we see that we get the initial value for temp, which is the path and the file name with the extension. Then we get the file name and just the extension, and then just the file name. You see that this is a file browser that locks you in to that starting directory that we've selected for the function. So if we go back in to our script and we change this parameter from a 0 to a 1, we save. Now when I click load selected, we get a much more comprehensive browser with a tree list on the left-hand side and a full list of not only files but folders. You still see that it filters out anything that's not a DAT. And if I drop this down, I can select all files, and you see that there's much more there. So using this type of browser doesn't exclude all of the files, because you can still drop this item down and select all files. And this is something that is a Windows property versus a Blue Open Studio. So that's just one thing to keep in mind. But now I can select Special 1, and you see that it has loaded it into our recipe screen. So now that we have shown how to load and how to save recipes, we'll show you how to access the recipe files outside of Blue Open Studio. So if I open Windows Explorer and I navigate to my application directory, which in my case is on my C drive and it's BOS_training. Unlike the alarms or the trending historical files, the recipe files are not located in a subdirectory. They're located right in the root. Now, as you can see, we have our two here, our roll1.dat and our special1.dat. So if I select to open these in Notepad, you see that I have just the values, no parameter name or anything like that. It's strictly the raw values. So I could also come in here and modify the values as well, as long as I know which parameters these values correspond to. This is the reason why at the beginning of the video, when I explained how DAT files can be saved through one recipe configuration file, but then loaded in from another, this is how it happens, because there are no parameters or tags associated with the values. It's just raw data. Now, if we were to go back in to the development and open our recipe worksheet and select to save it as XML, and then we were to come back in and do a save, and let's load our roll1 and then save that as well as an XML. And if I were to go back into my application folder, I now have two XML files with the same names but different extensions. So now if I were to open this in Notepad, you see that I have my XML coding or tags, but then I also see my tag names with the value. So the XML associates a tag name with the value. So this is a more secure way to use recipes because it gives a tag name. It gives the recipe configuration, because if I created a new recipe configuration file and attempted to load this in, the tag names wouldn't match and we would get an error. but I can also come in here and I can modify these values. So I could change what the value is for these without even going into Blue Open Studio. And that is one way where customers will create a batch of recipes without having to do it through the software. They'll create one blank recipe, copy it numerous times, and then just come in and change the values for each one without having to go in through the software, load it, make changes, and then save. Thanks for watching. If you have any questions, please feel free to contact ProFace America Technical Support by phone at 1-800-289-9266, option 2, or by email, support@profaceamerica.com. You can also visit our website, profaceamerica.com, for manuals, drivers, product FAQs, and other product and software information. Thanks again, and have a great day.